So good morning, everyone. So the paper is from the title is the Novel SSPP based highly sensitive EM biosensor for non-invasive measurement of the blood glucose. The authors are Devarati Datta, Namrata, and Dr. Anirban Sarkar. All are from IIT Mandi. Due to the unfortunate uh, inconvenience, like I'm presenting on their behalf. So like I'm trying to represent all those like trying to represent the paper. So if there is an in-depth query, you please let me know so that I can share this information to Dr. Anirban, or you may directly mail it to Dr. Anirban at the rate of iitmandi.ac.in. So the outline of this presentation is that introduction is there, and then they are trying to explain the sensor design, how this sensor is going to be designed, and then how it can be tested with different prototypes, including or using the DBI model. And then lastly, they are showing some tissue mimicking model, followed by the conclusion and references. If I go for the introduction part, so mostly if you know that in the biomedical application, it is always preferable to go for the non-invasive model as compared to the invasive model. But in the non-invasive model also, there are different ways are there, different type of techniques have already been established. Some of them are from the microstrip line, some of them are from the quasi TM, like using the microstrip or SIW line, etc. So here they are trying to measure the glucose or similar type of parameters in that case, and those they're trying to use using the non-invasive model, and they're trying to use that the since microstrip transmission line sometimes it's difficult to use for that type of cases, so they're trying to use some different type of models here using the spook plasmon mechanism. So the concept is there is that, so basically if you look into that, this type of geometry is the two-port type of parameters geometry is there. So from where the signal is coming from one end, it will be received by the another port, and the signal based on the information received by this hand or the glucose level present in our hand fingers, it can detect the change in the permittivity, and that will show us the glucose level. So this is the basic ideology or the basic mechanism of the structures like that. So as I mentioned earlier, that it is little bit difficult to use the transmission line or conventional transmission line or microstrip line in that case. So what they've tried to use, they have used the two techniques here combined. One is that they've used the central resonator inside the part, and they've used the spook plasmon based some transmission line in that case, which is not a microstrip transmission line. So this has some amount of gaps are there. So in between the bottom side, there is not no fully grounded is there. Some type of grounds are there. So why there is no ground? Because if you put the ground, the problem will happen is that the signal may not come properly from the ground side, or in that case, or maybe it cannot go. So that's why they have used the partial ground at the bottom side, but this ground is also not compulsory at the ground side. If you also remove this ground from the bottom, that can also give the response. It is mostly for the like enhancement of the performance. So basically here the signal is coming from the left side, which is the port one, and then there is some impedance matching technique has been done, and then some transmission line is there, along with this some small cuts are there, and then the resonator is in the central position, and after that again the another transmission line impedance matching part, and then the last one is the port two. So mostly this resonator they have used in such a way so that it can help us to detect the sample like permittivity or the glucose density by using the spook plasmon mechanism like that. And they are planning to put the sample in particularly this gap which is present. I hope my yeah. So the gap here, you can see that this gap they are planning to put the sample here, and by changing the sample without the sample and with the sample, that is changing the parameters, and that will give the response corresponding to that. So initially, without any sample, they have tried to measure this, or they are trying to characterize the structure. In that case, what they have found is that this resonator is showing some S21 and S11 mechanism. That means the signal for the left side, we can see that 6.5, there is a complete band stop response is there. Below and above that, there is a band pass type of response. That means that if you can consider the little bit of equivalent circuit, that part, this is one type of, it is giving one type of parallel LC mechanism, where the signal is coming at a particular response. And at this particular resonance, it is giving one type of band stop, and the signal is not able to pass across this. So that's why you are getting the, oh, sorry, it is, sorry, yeah, my bad. So it is actually passing everything at the S21, and at the other frequency, at the low frequency of resonance and the higher resonance, no signal is able to pass. So basically, you can consider that at the 6.356 or maybe 6.36 gigahertz, the signal is almost entirely passing with a very small amount of insertion loss. And we can detect that if we can put any of the sample in the center position or in this resonator position, that will change this frequency slightly from the offset. And from there, we can see that the how much shift will be there. From there, we can measure the resonance. So that is the idea, is that the resonator is giving some 6.36 amount of gigahertz frequency, and we're using this particular frequency to change the model. Now, this is without any sample. When we put the sample, the frequency will be shifting, but at the same time, the idea will be similar. And then what they tried to do is that they're trying to find using the Debye model. Debye model is mostly for the frequency dispersive materials. So if there are some liquid is there, and the liquid like have some different type of permittivity for different frequencies, so then we can calculate the permittivity of the frequency or permittivity of this particular different frequency from the different type of parameters. Like if we know the static permittivity low frequency means at the DC, and we know the permittivity at the high frequency, and then different frequency, we can determine the different values of the permittivity in that case. And what they're trying to do is that by changing, so this is one type of backside model. So if you know that there are different value of the concentration from 40 to 500 of the glucose concentration is there. So for different concentration, if you can use, if you know that epsilon infinite and epsilon static and the tau value, so you can determine the value of the permittivity at different particular frequency. So you know that if you know the value of the, or if you think about that the permittive value is unknown, so then from the permittive value which are determined here, you can determine the value of the concentration level. So this is one type of back process which we are using the Debye model. Debye model in the first order is like almost close to accuracy, but obviously if you can go for the higher order, you can get the accuracy. But first order Debye model is also okay to determine the level of the glucose. So after that, what they tried to do is that they have tried to mimic the entire system here. So there is a resonator is placed on the top of the resonator. They have considered that one tissue model, the 3-layer tissue model they have put. Like let's consider we can put one hand in that particular position, and if we can particular position we can put here. So inside the blood is there, muscle, fat, and skin is there. So this muscle, fat, and skin has some different permittivity values which can be available as Dr. Kushmanda also showed in the database. So and this blood level, from there we have that glucose concentration. So if the glucose concentration is changing from different value, the frequency is being shifted from one side or from other side. By saying this shift, we can find that okay, what is the value of the glucose concentration. Obviously, the sensing is little bit lower here. That means very highly sensitive device you need to catch up. But with time, it can be further improved that part. And they have not shown here, but the idea was this, that with this shift, when they're only shifting or changing the value of the muscle, fat, skin, it has been observed at their end that there is no shift in the frequency. So they are confirming that this shift, what is observed, this is mostly from the permittivity, from the glucose concentration level change in the blood. And from there, we can also go for the in the back on interpretation method that this is because of the changing the permittivity happens, the resonance is changing, permittivity due to the permittivity changing, and permittivity is changing because of the blood glucose concentration changes. And in this way, they can show in that part. Their structure, they are fabricated, and hopefully they are going to publish it in the journal in the coming days. So ultimately, if you can come to the conclusion in the part, so this is a non-invasive method they are trying to use to make for the particularly in the diabetes detection, but other type of medical detection or medical parameter detection can also be done. So they have input some inner sensitivity there. And as I mentioned, that the idea is that mostly in the planar design, instead of using the microstrip and the or other conventional one, they're trying to use the other type of designs like using a split plasmon, and the design is also low cost and easily replicatable using the PCB technique. So this is the references. Thank you.